Did you know that the brilliance of colors of crackers is a result of chemical reactions? Have you ever wondered why silver gets tarnished? Crackers contain chemical substances like aluminium, barium, calcium, etc. that burn in oxygen to impart a silvery white sparkling effect with green and orange colors. Thus, elements get oxidized when you burn crackers. Similarly, silver reacts with hydrogen sulfide in air and forms black silver sulfide. Thus, silver combines with sulfur in this reaction. All chemical reactions can be classified based on the different ways in which elements react with each other. In this lesson, you will learn how to classify reactions. At the end of this lesson, you will be able to classify chemical reactions, describe the characteristics of each type of chemical reaction, identify exothermic and endothermic reactions. Chemical reactions vary depending on the chemicals involved in the reaction as well as the environment of the reaction. For example, the roughing of an iron nail is an oxidation reaction. On the other hand, the digestion of food in our body is a decomposition reaction where the complex food substances are broken down into simpler substances like glucose that give energy. Chemical reactions can be classified into following types: combination reactions, decomposition reactions, single displacement reactions, acid-base or neutralization reactions, double displacement reactions, combustion reactions, and oxidation, reduction or redox reactions. Let us begin with combination reactions. A combination reaction is one in which two or more reactants combine to form a single product. The reactants may be elements or compounds. The general form of the reaction is A combines with B to form a single substance, C. For example, coal burns in oxygen to form carbon dioxide. In this reaction, the two elements, namely carbon and oxygen, combine to form a single product, carbon dioxide. Let's take another example of calcium oxide reacting with water to form slaked lime or calcium hydroxide. In this reaction, the two compounds, namely calcium oxide and water, combine to form a single product called slaked lime. You must remember that a combination reaction has many reactants but only one product. Decomposition reactions are the opposite of combination reactions. Decomposition reactions are those in which a substance splits into two or more simpler substances. The general form of a decomposition reaction is AB decomposes to give A and B. Decomposition reactions use heat, electricity, or light energy. Decomposition through the action of heat on a substance is called thermal decomposition. For example, calcium carbonate on thermal decomposition gives calcium oxide or quicklime and carbon dioxide. Decomposition of a substance by passing current through it is called electrolysis. For example, when electric current is passed through acidified water, it decomposes to give hydrogen gas and oxygen gas. Finally, the decomposition reaction resulting from action of light energy is called photolysis. For example, when silver chloride is exposed to light, it decomposes to form silver metal and chlorine gas. Remember that a decomposition reaction always has one reactant and many products. Now let us look at the displacement reaction, beginning with the single displacement reactions. A single displacement reaction is a reaction in which an element reacts with a compound to substitute or displace an element in that compound. The result is a new compound. The general form of the reaction is written as C displaces A in AB to form CB and A. Generally, in a single displacement reaction, a less active metal is displaced by a more active metal. For example, in the reaction of magnesium with copper chloride, magnesium takes the place of copper to form magnesium chloride. It is important to note that in a single displacement reaction, one of the reactants is always an element. For instance, let's consider another reaction where magnesium sulfate reacts with copper chloride to form magnesium chloride and copper sulfate. Even though this reaction seems similar to the earlier example, it is not a single displacement reaction because both the reactants are compounds that exchange ions. An acid-base reaction is a special kind of displacement reaction between an acid and a base. Most acids have the general formula HA, where A is an anion, while most bases have the form BOH, where B is a cation. In an acid-base reaction, the hydrogen ions of an acid react with the hydroxide ions of a base to form water. Therefore, in the general form of an acid-base equation, HA, an acid reacts with BOH, a base, to produce water and a salt, BA. An example of an acid-base reaction is the reaction between hydrochloric acid and sodium hydroxide. In this reaction, the chloride ions in hydrochloric acid and the sodium ions in sodium hydroxide react to produce sodium chloride or common salt and water. Another example of an acid-base reaction is the reaction of sulfuric acid with sodium hydroxide. In this reaction, the sulfate ions of the sulfuric acid react with the sodium ions of sodium hydroxide to produce sodium sulfate salt and water. Do remember that in an acid-base reaction, one of the products is always water. A double displacement reaction involves an exchange of ions between two compounds. The general form of a double displacement reaction is AB and CD undergo double displacement to form AD and CB. A classic example of a double displacement reaction is the reaction of magnesium oxide with calcium sulfide. In this reaction, magnesium and calcium ions interchange their places to form magnesium sulfide and calcium oxide. This reaction is known as a double displacement reaction because two compounds, magnesium sulfide and calcium oxide, are formed by the displacement of magnesium and calcium ions with each other. When the two reactants involved in a reaction are compounds, it is a double displacement. As you saw, in double displacement reactions, compounds exchange ions. However, in a combustion reaction, there is no exchange. In a combustion reaction, when all elements in a carbon compound combine with oxygen, they produce carbon dioxide and water. Thus, combustion reaction is the burning of a substance in the presence of oxygen, resulting in the release of energy, carbon dioxide and water. For example, ethylene burns in the presence of oxygen to produce carbon dioxide, water and heat. As the combustion reaction results in the release of heat energy, it is an exothermic reaction. Remember, a combustion reaction cannot occur without oxygen. There are some reactions that we see every day Most of these reactions involve oxidation, reduction, or both. Oxidation reaction involves the addition of oxygen or the removal of hydrogen from a substance. This is a simple combination reaction. Two common examples of oxidation are rusting and rancidity. When an article made of iron is exposed to moist air for a long time, it turns reddish brown due to rusting. Here, iron is oxidized to form iron oxide. Chemically, rust is known as hydrated ferric oxide. Rusting of an iron article can be prevented by coating the surface with enamel, paint, or red lead oxide. Rancidity is the condition produced by the oxidation of fats and oils in food. It is marked by an unpleasant smell and taste. Two ways to protect food from rancidity are addition of an antioxidant. An antioxidant is a substance that prevents oxidation. Two common antioxidants used in food are butylated hydroxyanisole (BHA) and butylated hydroxytoluene (BHT). By packing food in nitrogen gas, nitrogen prevents oxidation of food. For example, rancidity in potato chips can be prevented by flushing the bags with nitrogen while packing. A reduction reaction involves addition of hydrogen or removal of oxygen from a substance. It is exactly the opposite of an oxidation reaction. For example, the formation of hydrogen sulfide involves a reduction reaction. In this reaction, when hydrogen is added to sulfur, sulfur gets reduced to hydrogen sulfide. Another example of a reduction reaction is photosynthesis. In plants, carbon dioxide and water are reduced to carbohydrates in the presence of light and the pigment chlorophyll. Oxidation and reduction reactions occurring together are known as redox reactions. In a redox reaction, a substance that gains oxygen is said to have been oxidized, and the one that loses oxygen is said to have been reduced. Let's use an example to explain redox reaction. Copper oxide on heating with hydrogen forms copper metal and water. In this reaction, the oxygen is removed from copper oxide. Here, copper oxide is reduced to copper. On the other hand, hydrogen is changed into water. That is, oxygen is added to hydrogen. So hydrogen is oxidized to water. Thus, we find that in this reaction, oxidation and reduction occurs together. Therefore, it is redox reaction. All types of reactions result in either the release or the absorption of energy. Depending on energy considerations, chemical reactions can be classified into endothermic and exothermic. Endothermic reactions are those chemical reactions in which energy is absorbed. The energy absorbed is often in the form of heat energy or electrical energy. For example, sending electrical energy through a sodium chloride solution can cause it to break into its constituents, sodium and chlorine. On the other hand, exothermic reactions are the chemical reactions in which energy is released. For instance, when water is added slowly to a small quantity of quicklime or calcium oxide in a beaker, slaked lime or calcium hydroxide is formed and the beaker gets heated up. This is due to the evolution of heat during the reaction. Therefore, this is an exothermic reaction. All combustion reactions are exothermic reactions. For example, in the burning of coal, a large amount of heat is liberated. Therefore, it is an exothermic combustion reaction.